Alright, welcome back to Mr. P's solution videos. So let's take a look at our first one, number 8. Number 8 I've already started working on here. I got 5 times the square root of 45. I'm thinking, what are my perfect square factors of 45? 5 times 9 times 5. 9 times 9 and 5 are my factors of 45. I want a nice big perfect square factor of 45. That would be 9. When I pull that 9 out, I get 3. When I take the square root of 9, I get 3. So I have 5 times 3 times the square root of 5. That's 15 times the square root of 5 would be my correct answer. That moves us on to number 9. It says 7 times the square root of 147. I'm going to copy my 7, right? And that's not going to change, but I'm going to need to rewrite that 147 as a multiplication of its factors, right? So I'm thinking, what are my factors of 147? I've tried 16, I've tried 36, I tried 25, I've tried all kinds of things. Actually, it comes out to 49. So 49 and 3 are my factors of 147. So I do 7 times square root of 49 times 3. I take that square root of 49, I get 7 times 7. I multiply that again by the square root of 3, which is left, and I get 49 times the square root of 3 is my answer for that one. Okay, that's number 9. Number 10 we did in class together. Great work, whoever worked on that one with me. Number 11 we have 4 times the square root of 2, 3 times the square root of 5, and 6 times the square root of 2. When I combine those, 4 square root of 2 and 6 square root of 2, I get 10 square root of 2, right? That's just like a variable. 10 square root of 2 plus 3 square root of 5. I think, are all my square roots simplified? They are. I am done. Okay, so we can think of this 4x plus 6x, and then that's a 3y. That's kind of how we think about it to finish that one. Number 12 says 12 square root of 7 plus 9 square root of 2 minus 3 square root of 7 plus 6 square root of 2. We're going to find our common terms. We got square root of 7 here, square root of 7 here, square root of 2 here, square root of 2 here. So I'm going to do 12 minus 3. Take those 12 and that 3. I get 9 square root of 7. I add to that 9 plus 6 gives me 15 square roots of 2. Both of those are simplified square roots. I'm done. Right, moving on to number 13. 5 square root of 3 times 7 square root of 3. We talked in the last video about how square root of 3 times square root of 3 is just going to give me a 3. And I already have that 5 multiplied out front and a 7. So 5 times 7 is 35, and 35 times 3 is 105. My answer is a nice even 105. 15, I have 4 times square root of 2 times 3 times square root of 5. I'm going to multiply those square roots, and I'm going to multiply my coefficients. So I'm going to have a 12 when I multiply my coefficients times square root of 10. I think, does 10 have any factors? Perfect square factors for me are 4, are 9 factors of 10. No, so I'm done. Box that one in as well. Number 16 is next. I have 8 over 2, or 8 times square root of 6 over 2 times square root of 2. I can rewrite that. I'm going to use my property that I can rewrite those square root of 6 over square root of 2 like that, both inside a larger square root. And I'm going to have 8 over 2 out front. What do I know 8 over 2 is? I know 8 over 2 is 4 times 6 over 2 is 3. So 4 times square root of 3 is my answer. 17. We talked about how square root of 3 and square root of 3 were just like variables we can cancel. So now we're left with 18 over 3, which is 6 times. And then we got square root of 15 and square root of 3 and 12 over 2. I'm going to use that, take that 12 over 2, I'm going to divide that, get 6. And multiply that by my property that tells me 15 over 3 inside a larger square root is a valid way of rewriting that. And then I'll rewrite that as 36, multiplying my 6 and my 6 times the square root of 5, and I'm done. We did 18 together in class. Great work, Andrew. Number 19, we're going to multiply by square root of 2 on the top and bottom. You think, why are we multiplying? That's, again, what we call radicalizing the denominator. So when we radicalize the denominator, we're essentially multiplying by 1, right? Square root of 2 over square root of 2 is 1, but we want to multiply by those so we can get rid of the radical in the denominator. On the bottom, square root of 2 times square root of 2 gives us just 2, regular 2, we should know that. And then 8 times square root of 2 on the top. That is our answer, because square root of 2 is a non-reducible square root. Brings us to number 21, 25 times square root of 3 over square root of 5. Again, I'm going to use this opportunity to radicalize the denominator, so square root of 5 over square root of 5. So now I'm going to have 5 on the bottom. I'm going to have 25 times square root of 15 on the top. And then I think, does 15 have any factors which are perfect squares? So let me think of my perfect squares less than 15. 1, obviously. 4, is 4 a factor of 15? Nope. 9, is that a factor of 15? Nope. And then my next one is 16. So actually 15 is a simplified square root. Now I lastly can divide those parts, and I get 5 times square root 15, and I'm done. Number 22 and 23 we did in class. Great work, everybody. That was 55. I'll box that one in. 24 and 26 is all we have left in this video. So 22 square root of 3 plus 5 square root of 2 plus 5 square root of 2 plus 3 square root of 3. That's our situation we have here. So again, this is just like when we add polynomials, right? If we had 3x squared plus 2x plus 3y, or 3x minus 2, we can just get rid of the parentheses and add all of our like terms there, and then we get 3x squared plus 5x minus 2, right? So the same thing occurs here. Since we have a plus sign, we can just rewrite this adding our like terms. So 2 square root of 3 and 3 square root of 3 gives us 5 square roots of 3, and 5 square root of 2 and 5 square root of 2 gives us 10 square root of 2. And I'm done. Those square roots are reduced. Pretty easy one. Number 26. I have a bunch of square roots that are multiplied by coefficients that are not the same number in the square root. So I'm going to have to do what? I'm going to have to simplify the square roots. I have 5 times square root of 54. Let's work with that one first. Let's rewrite that. 5 times, what are some factors of 54? What about 9 and 6? Okay, then we pull out that one. That becomes 5 times 3 square root 6. In the end, we have 15 times square root 6. Okay, we've rewritten that one. Let's rewrite this one. 2 times square root 27. What are my factors of 27? I've got 9 and 3. That becomes 2 times 3 square root 3. When I take the square root of the 9, just like I took the square root of 9 over here to get 3. And that gives me 6 square root 3. And that's being added. Again, don't forget your plus signs in each of these steps. And this one, I'm rewriting my 5 square root of 16 to be 5 times the factors of 16, which would be 4 and 4. But what do we know about 16? That's a perfect square. So 5 times 4, so that would be minus 20. Minus 20 in here. Are we done? Yes, we are, because 6 and 3 are simplified square roots, and none of those are quote-unquote like terms having the same square root multiplied by a coefficient. So we are done there. Thanks for watching.